Hello and welcome my excellent A students. In this video we will be looking at multiplication in modular arithmetic, but as it is our usual practice, we start off by solving our previous take-home assignments. So let's start with that. To reduce to its simplest form, question 1, minus 7 in modulus 9. Like I explained in the previous video, you assume that you are adding 0 to this minus 7 plus 0, but the zeros in modulus 9 are multiples of 9, like 9, 18, 27, and on. So you pick the smallest number that would make the question you are working with solvable, and that is the first 9. 9 in modulus 9 is actually 0. So if you say minus 7 plus 0, we are still saying minus 7 plus 9 because we are working in modulus 9. So minus, then remember the concept I explained earlier. Which number is greater is 9. What sign does it have? A plus sign, positive. So our answer will be positive. So 9 minus 7 will give us 2. Minus 7 in modulus 9 is actually 2. Question B, minus 13 in modulus 5. So we assume that we want to add 0 to it, but in modulus 5, zeros are multiples of 5, like 5, 10, 15. So we take the smallest number that makes this question solvable. In this case is 15. So minus 13 plus 15. 15 is the greater number and is the one with the positive sign. So our answer will be positive, and then 15 minus 13 is 2. So minus 13 in modulus 5 is actually 2. This minus is for this 45. This 28 has an implicit plus sign. So since the greater number, which is 45, has a negative, our answer will be negative. And then when we do 45 minus 28, we would have 17. So our answer is minus 17 in modulus 7. To convert this to a positive number, this becomes minus 17 plus 0. Note that 0 in modulus 7 will be multiples of 7. So we have 7, 14, 21. So we pick the smallest number that makes this solvable. In this case is 21. So minus 17 plus 21 will be plus 21 minus 17, that's 4, plus 4. So 28 minus 45 is actually 4 in modulus 7. So 9 minus 8 will give us 1. 1 is a valid residue in mod 6, so we leave it as that. The possible residues 0, 1, and 2. And then we draw our table. 0 minus 0 will give us 0. 0 minus 1 is minus 1. But in modulo 3, 0, you can see minus 1 plus 0. But 0 in modulus 3 is multiples of 3. So it could be 3 itself, 6, 9. So we pick the smallest number to make this solvable, which is 3. So minus 1 plus 3 will give us 2. So this is 2. So 0 minus 2 will give us minus 2 in modulo 3. Minus 2 plus 0. But 0 in modulo 3 I have highlighted it. So we pick the least value that makes this solvable, which is 3. Minus 2 plus 3 will give us 1. 1 minus 0 will give us 1. 1 minus 1 will give us 0. 1 minus 2 minus 1, so that is 2. 2 minus 0, 2. 2 minus 1, 1. 2 minus 2, 0. And we move to the topic of today proper, which is multiplication modular arithmetic. 2 times 4 will give us what? 8. 8 is not a valid mode 3 residue. Mode 3 residues are 0, 1, and 2. So we have to convert this to a valid residue. So we divide by the modulo we are working with. 8 divided by 3. That will give us 2 remainder 2. So therefore 2 times 4 will give us 3. Will give us 2. This remainder in mode 3. 9 times 15 or 25. 125 is not a valid mode 6 residue. Possible residues in mode 6 are 0, 1, 2, 3, 4, 5. So we have to divide 125 by the mode, which is 6, and that will give us 20 in the 5. 9 times 15 in modulo 6 will give us 5. 17 times 15 in modulo 7. So 17 times 15 would give us 255. Well, obviously, this is not a valid mode 7 residue, because valid mode 7 residue start from 0 up until 6. So to get that, we have to divide 255 by the mode we are working with. That will give us 36 in the 3. Will give us 3 in modulo 7. To prepare a multiplication table in modulo 5, identify the set of residues. That will be 0, 1, 2, 3, 4. 0 times 0, 0, 0 times 1, 0, 0 times 2 times 3, 0 times 4, 0. 1 times 0, 0, 1 times 1, 1, 1 times 2, 2, 1 times 3, 3, 1 times 4, 2 times 0, 0, 2 times 1, 2, 2 times 2, 4. Is 4 a valid? Yes. 2 times 3, 6. 6 is not valid, so we do 6 divided by 5. 1 remainder 1, we write 1. 4 times 2, 8. 8 divided by 5, 1 remainder 3, we write 3. 3 times 0, 0, 3 times 1, 3, 3 times 2, 6, so we write 1. 3 times 3, 9. 9 divided by 5, 1 remainder 4, we write 4. 3 times 4, 12. 12 divided by 5, 2 remainder 2. 4 times 0, 0, 4 times 1, 4. 4 times 2, 8. That's 1 remainder 3, we write 3. 4 times 3, 12. 12 divided by 5, 2 remainder 2, we write 2. 4 times 4, 16. 16 divided by 5, 3 remainder 1. So we write 1. You are asked to construct a table for the set 2, 3, 5, 6 using modulo 7. But instead of the usual way of making the values in the table to be the possible residues, we have been given specific residue to use, specific set of residue. So we would ignore the standard and use a specific set that has been mentioned. The set 2, 3, 5, 6, and that's what we would use. So we have to draw our table. Remember, this is in mode 7. It's important because when we are recording our remainder, we have to be careful. In mode 7, the possible residues, that is the possible numbers that we can write in this table, 0, 1, 2, 3, 4, 5, and 6. So 2 times 2 is 4. Is it valid? Yes, it's valid. 2 times 3 is 6. Is valid. 2 times 5 is 10. Is not valid. So we do 10 divided by 7. 1 remainder 3. So we write 3. 6 times 2, 12. Is not valid. 12 divided by 7. That's 1 remainder 5. 5 is what we write. 3 times 2, 6 is valid. 3 times 3, 9. 9 divided by 7, 1 remainder 2. So we write 2. 3 times 5, 15. 15 divided by 7, 2 remainder 1. So we write 1. 3 times 6, 18. 18 divided by 7, 2 remainder 4. So we write 4. 5 times 2, 10. So we write, that's 1 remainder 3. We write 5 times 3, 15. We write 1. 5 times 5, 25. 25 divided by 7, 3 remainder 4. We write 4. 5 times 6, 30. 30 divided by 7. That's 4 remainder 2. So we write 2. 6 times 2, 12. This is it. We write 5. 6 times 3, 18. That will be 4 because 2 remainder 4. 6 times 5, 30. 4 remainder 2, we write 2. 6 times 6, 36. 36 divided by 7, 5 remainder 1. We write 1. So the first question, we are told that m times m will give us 2. So the first thing we want to identify, what are the values of 2 in this table? We have 2 here, we have 2 here, and we have 2 here. So 2 is here. What gives us this 2? 3 times 3, and we have m times m. So that means m is 3. Why don't we pick these two? Because for these two, we have 5 times 6. And 5 is different from 6. M cannot be 5 and be 6 at the same time. So the only thing that satisfies this is this one. Because 3 times 3, M is 3. So 3 times 3 will give us 2. So that's how we get that M is 3. Now for the other question B. For the other question B, we are told that N times into bracket N times 6 would give us 3. So the first thing we need to know is that what are the values of 3 in our table? The values of 3 in our table, we have 1, this is a 3, this is another 3, just 2 values. And in the first value, it is 2 times 5, give us 3 in this case. And in this case, 5 times 2, 5 times 2, that will give us 3. So how do we now get what N is? We know that whatever N is, it also must give us N times 6 has to be either 5 or 2. Do you understand? For this equation to be satisfied, if you are picking first option, let's say option 1, option 1. Option 1 is to pick 2 times 5 is equal to 3. That means you are saying n times 6 is equal to 3. If you are picking this option, then that means you are saying n is 2 and n times 6 is 5. Now let's confirm if this is correct. If you are picking this option, we are saying n is 2 and so n times 6 is 5. And because we say n is 2 here, let's check. 2 times 6, will 2 times 6 give us 5? You come to our table. 2 times 6 give us 5, which is correct. So 2 times 6 give us 5, which is correct. So that means that our n is actually 2, because 2 times 6 will give us 3, because 2 times 6 gives us 5 times, then 2 times 5 now give us 3. So what satisfies that is this. Option 2 is picking 5 times 2 is equal to 3. That means we are saying 2 is equal to 5 times 6. 5 times 6 is 2. So that is also correct. So we can say n is 2 or n is 5. Either way is correct. Take home question for this video. Question 1. Solve 4 times 7 in mode 8. Question 2. 6 times 9 in mode 5. Question 3. 19 times 28 in mode 9. I'll see you in the next video. And remember, if it didn't make sense the first time, watch it again. That is the MathSense way.